I think.
Got it.
Okay. It allowed you to do it without any code.
Yeah.
Okay, it probably recognizes you. So.
Hi, Nicole.
Hello.
Hi.
I think we're about to enter a loop where I share my screen of ourselves. Hi. So let me make you both co-hosts. Okay. All right. So we're being live streamed. Okay. Thanks for joining. Sorry for the late link. Hopefully that was okay.
No, it's fine. Should I?
Yeah, can you try to share your slides? And...
Yes.
Oh, just so that you know, we are live on YouTube, but I don't think we have any viewers yet.
Yeah, that just appeared.
Okay.
Perfect. Right. So what time is it now? Okay, we have a few more minutes before officially starting. Nicole, do you want to take questions? Are you happy with questions during the talk, if there is any, or do you prefer them to be at the end?
I think, questions during the talk is fine. That's great.
Okay. So I'll do that, and you don't have to monitor the chat. We'll monitor the chat if there is any question there, and relay that to you.
Sure.
Okay. Yes, let's wait a little bit.
So this is 1 hour, right?
Yeah, 1 hour, and including some questions.
Yeah.
Right. So we're going to start in 1 minute or two. I just want to make the announcement that if you have questions, feel free to unmute yourself and ask. And this is recorded. This is also live streamed on YouTube. So if you're not comfortable asking questions or you don't want to appear on the recording, you can also just type your question in the chat. And we're going to be monitoring the questions and relaying them to Nicole during the talk. You can also just wait until the end of the talk and ask questions at that point. So whatever you feel more comfortable with. And when you're not actively asking a question, please mute yourself just to avoid any interference. So that's about the practical aspects, and the talk is recorded and will be put online afterwards. So, right. So maybe we can wait 1 more minute and then start.
No worries.
Thanks.
Hi, Juba.
How's it going? It's been a long time.
Great. Where are you these days?
I'm in Atlanta right now at Georgia Tech.
You're in Toronto.
Atlanta, yep.
And Atlanta. Okay.
Yeah.
Cool. Yeah, I'm in Princeton at the moment in a hotel room.
Oh, okay. What are you doing there?
Nima's giving a talk in the econ department, so I'm.
Okay, that makes sense.
We're on our way back to Boston for Thanksgiving. Stopped in.
I see. Nice. Actually, kind of lost track. Like, are you in New York or Boston these days?
Well, we're going up there for Thanksgiving because my family lives in New Hampshire, but I actually transferred to the New England lab in February or March or something.
Okay.
So, but I've been living in State College, Pennsylvania.
Okay, I see. So you've been like all over the place.
Yeah. Well, we're still fully remote at Microsoft. In fact, our internships are going to be remote even because almost surely because the lab wants, or the company wants full-time employees. They want to sort of phase people back in once we start going back. And so full-time employees will have to be back for 6 months before we have visitors like interns. So, because intern seasons, we like to start our interns in May, and we're not back yet.
Okay, I think we're going to start. So I'm going to start the recording. So let's see, we got onto the cloud. So thanks everyone for joining us. We're delighted to have Nicole Immorlica give a talk today on communicating with anecdotes. So Nicole is a researcher at Microsoft Research and has done a lot of amazing work, in particular on algorithmic game theory. And she's going to tell us about what communicating with anecdotes. And I'm going to leave the floor to you, Nicole. And yeah, if you have questions, please feel free to ask during the talk, and we're going to relay them, or you can just unmute yourself.
Great, thank you. Thanks for inviting me. I'm pretty excited to present this paper to this group of people because, it's really an econ paper, but I think it is trying to pursue this agenda I have of taking data seriously, or the fact that data is, in my mind, kind of like the fundamental particle in a physics analogy by which any transaction between human beings interact. And so I want to try and take that very literally and see how that impacts economic models. And so this paper is in sort of that line of inquiry. It's joint work with Niga Haktalab, who's now at Berkeley, Brendan Lucier and Marcus Mobius, my colleagues at Microsoft Research, and Divya Mohan, who is a postdoc at Tel Aviv University. So in communication, games are, one of a very studied model in economics. And the way that we think about a communication game in a traditional setting is you have a sender. The sender is going to talk to the receiver about the state of the world. You might expect communication to have the receiver then talk back to to have people talk to each other in a repeated fashion, but that gets very complicated. So what a lot of the literature and what I want to focus on is just a one-way communication game where there's one sender and one receiver, and the sender is going to talk to the receiver. They're going to send a message to the receiver. And the message has something to do with the state of a world. So examples of this might be like politicians who are going to have a State of the Union address and talk to their constituents about policy decisions. You might think about newspapers where, say, the New York Times is going to publish a news article about current events in a form of communication to the readers of the New York Times. And so there's a lot of examples like this. And the key sort of features of this game that I want to discuss is that there's fundamentally some information asymmetry. So the sender knows more than the receiver about the state of the world. Okay, so if the state of the world is the danger of COVID, maybe the newspaper knows more about the danger of COVID because the journalists have done a bunch of research about it. And so the sender, the newspaper there, knows more than the receiver, some average random reader of the New York Times, about the state of the world being the danger of COVID. So there's this information asymmetry. That's what makes the communication interesting, because the sender has to say something for the receiver to learn something. There's also, and this will be something that's not pervasive in the literature, but that I want to focus on in my paper, the idea that there's hard evidence. And this is really like the idea of the fundamental particle of communication is data. Newspapers and politicians in this example, but in many other examples, it holds that what we communicate is not some arbitrary message, but rather facts. And these facts are assembled through our research and anecdotes, and that's where the title of the paper comes from, that we hear about interactions with people in the world around us. And the sort of third key feature here is, why are we communicating in the first place? Why does the receiver even care? And that's because the receiver has some agency, and they have to take an action, maybe how much am I going to wear a mask to help prevent COVID. And so, the receiver gets to decide how to act. This can't be dictated, or it's hard to enforce a particular action. So there's some sort of agency for the receiver, and the receiver's choice is then influenced by her beliefs about the state of the world. So formally, this will mean that the payoff of the receiver is a function of the state of the world and the action. And so the receiver cares to learn about the state of the world to help decide, inform the decision about what action to take. And furthermore, this action that the receiver is taking also impacts the sender. So the sender has some stake in the outcome, right? The sender really wants the entire country to wear masks. And so the sender's utility is impacted also by the state of the world and the actions of the receiver. Okay, so this is kind of like the general setup, just a little bit more detail before I get into some motivation. We have, I've already talked about the sender as having some more information about the state of the world than the receiver. We model this information structure as the sender having a signal that's payoff relevant, that is correlated with the payoff relevant state of the world. And in order to make this into a game, I have to give the sender and receiver formally some action spaces. And so the sender's action space here is a strategic choice of what communication scheme they're going to use to map the signal that they have about the state of the world to the information that they communicate to the receiver. And, this is in the literature, this is a generic mapping. I will eventually restrict this mapping to be that we have to communicate data, and we can't just communicate arbitrary messages. But in general, there's just some mapping from the signal space to an arbitrary message space. And the sender's strategic choice is to pick this mapping. The receiver is going to have beliefs about the state of the world, but is not fully informed. In fact, in my model, the receiver is going to be fully uninformed in a sense I will make precise later. And then the action that the strategic choice of the receiver is the action that she takes based on what information is communicated, which will, allow her to update her beliefs about the state of the world, and then the action choice that she selects. So the important point here, as I emphasized on the last slide, is that this receiver's action is payoff relevant for both the receiver and the sender. And this is what makes communication like an interesting thing. There's some tension here because the preferences of the receiver and sender over the action of the receiver might be misaligned. And so agents are going to pick these, communication schemes and action mappings in order to maximize their utility and expectation over the state of the world and the signal that's generated from the state of the world. In particular, I'm going to be focusing on a model in which the sender and receiver's preferences are misaligned, in that the sender might want, there's some state of the world data, and the sender would like the receiver to take an action that's the state of the world plus a shift ms. So you can think of ms as being negative in this example, but it doesn't have to be. And so, the sender is maybe a little bit to the left, a little bit leftist, if you like. The receiver, on the other hand, is a little bit to the right, so a little bit rightist. And the receiver, if they knew the state of the world, would like to take an action that's the state of the world plus a shift MR, which you can think of as being positive for the context of the talk. Okay, so the fact that there's MS and MR are different is inducing a preference misalignment between the sender and receiver, and is sort of giving the sender a temptation to try and persuade the receiver that the state of the world is left of where it really is. I'd like to just, fix some, do you have a question, Clement?
Yeah, just about the models. So yeah, we're really talking about communication. There is no computational issue. We assume they can maximize things efficiently on both sides. There's
no computational issues.
Okay. And do they know each other preferences? Are they aware of?
So I'll make all the assumptions precise later, but MS and MR, yeah, we know what the preferences are of the other side. The unknown here is the receiver doesn't know the state of the world.
Thanks.
Okay, so let me work through an example here. So we have one of the examples I introduced in the beginning was politics. So politicians speaking to their constituents. So you could imagine that you have a politician, a president, say, and this president is going to have a signal that's correlated with the state of the world. This signal might come from, research that she does or stories that she hears from her constituents. And then the communication scheme that the president selects is maybe impacted by her speechwriters. So she hires some speechwriters, she gives them all this data, the speechwriters come up with what she's going to say. That's the communication scheme, the mapping from the data that she gives to this black box of speechwriters to the speech that's output. And the receiver might be, for example, employers. Maybe the state of the world that everyone's talking about is how much different employees are paid. And so maybe the employer has some beliefs about the gender wage gap. And the action that the employer is taking is how much the employer wants to pay their male versus female employees. And maybe, people have different preferences over what is an ideal gender wage gap. Maybe the president really values fairness over free markets, whereas the employers are trying to maximize profits. And if women are paid systematically less than men, they just want to pay women systematically. They want to underpay women in order to match the market rate for women employees. And so this is one example of a communication game, and the president will then make statements about the gender wage gap and what the ideal policies should be, thereby trying to influence the actions of the receivers in order to make them close the gender wage gap, because the president prefers that the gender wage gap gets smaller. Another example that I mentioned in the beginning was newspapers. So here we have journalism. We have, say, the New York Times. And I already discussed this example a little bit, but you can imagine that the journalists in the New York Times are doing research into COVID, and they're going around and interviewing people and scientists and whatever and learning a lot about COVID. And the newspaper has some editorial policy about what sorts of stories and they're going to print and what things they're going to print in those stories. The receiver here might be the reader, who has some beliefs about the danger of COVID and the effectiveness of wearing masks. And the action that the reader is going to take is the fraction of time that the reader will spend wearing masks. And you could imagine that maybe the newspaper is a leftist newspaper like the New York Times, values health over personal freedom more than the readers do, and so wants to print articles that convince the readers to wear masks more often than they do, than they would want to if they knew the effectiveness of masks. Okay, so those are two examples I have in mind. Now, let's see a little bit like what the literature would do, the sort of standard economic literature would do in these settings. The first kind of thing that a lot of the older literature does is say, okay, without loss of generality, the sender is going to say something to the receiver, and then the receiver is going to take an action. And we can have what is called this obedience constraint, whereby for anything that the sender says and action that the receiver takes as a result, we can just kind of abstract away from that whole mapping and put it into a black box, which simulates what the sender would have sent and what the receiver would have done, and thereby has the sender simply tell the receiver what action she would have done if we had gone through this underlying communication scheme and action rules. So for any equilibrium in which you have some particular communication scheme for the sender and action rule for the receiver, we can do this kind of simulation exercise. And I think this is very natural for computer scientists, but it's sort of a aha moment in economics, right? That like we can, without loss of generality, have a corresponding equilibrium in which the sender simply says to the receiver, wear a mask 30% of the time. And the receiver then does that thing, wears the mask 30% of the time. And hence the sender it's called the obedience constraint, because the sender is constrained to say something that's incentive compatible for the receiver to follow. But so long as the sender's, so long as that constraint is satisfied, then this will also be an equilibrium. Okay, so anything we can implement in an equilibrium with any sort of communication and response by the receiver, we can also implement in this direct scheme where the New York Times says, reader, wear a mask 30% of the time, and then reader does it. And so, this is what I take issue with, because I think this is not how we communicate. And the point of this paper is to unwrap this obedience constraint, like throw it out the window and say, what if we actually try to communicate with facts? But before I go there, let me just give you a little bit of background on what happens when we communicate using these direct schemes. So in the literature, there's a lot of work in this line. I think it was kind of initiated by this beautiful paper of Crawford-Sobel. So when the sender and receiver are kind of simultaneously best responding to each other, so like the sender is trying to convince the receiver that the state of the world is to the left, and the receiver is trying to then like anticipate that and undo the bias, we get a babbling equilibria. So it's always the case that it's an equilibrium for the sender to say nonsense and for the receiver to ignore it. Or let's say if you want to do this in a direct revelation world, you could say the sender always says 0 no matter what the state of the world is. Like where 0 is the expected, the action that the receiver would have taken without any additional information from the sender. Okay, so you always have these kind of babbling equilibria. You can also get these separating equilibria where the sender communicates everything she knows, or that is, tells the receiver exactly how to optimize, and the receiver obeys. But kind of in between these are these pooling equilibria, where the sender looks at a bunch of different states of the world, pulls them together, and tells the receiver what the optimal action would be for those pooled states. Okay, so I'm not gonna, I as the sender, maybe I know that the masks are 73% effective, but I'm never gonna say that. I'm just gonna say instead that masks are 70 to 80% effective, and therefore you should wear them like, 75% of the time. And so those are the pooling equilibria. And this result of Crawford-Sobel says that the finest pooling equilibrium, so when I pool as few states as possible, that's going to give highest utility to everybody. And how fine the pool can be is dictated by how different our preferences are. So it's dictated by the preference misalignment. As our preferences become more aligned, we can get finer and finer pools and sense better and better equilibria. With commitment, the sender, now I'm saying like the sender can commit to the communication scheme, and then the receiver best responds to the scheme that the sender committed to. So they're not choosing their strategies simultaneously. Then we kind of lose this temptation to try and persuade, because I know if I try to persuade the receiver as a sender, the receiver will correctly undo my persuasion. And hence there's like, you know, that I won't be able to gain anything from this. And so there's this famous result of Commensa against Gao that sort of is some, like, you know, representative of this literature, in which they say that the sender can persuade the receiver by pooling. And so there's a very famous example here that I think is quite beautiful. I think in the interest of time, I'm going to skip it, but I encourage you to go read their paper, because I think that this is a really nice kind of sender receiver communication game result here, where you can see that the sender can persuade can gain utility by withholding information from the receiver. So those papers are both relying on the fact that I can, or you know, they're both not restricting at all the message space of the sender. And what I want to do is restrict what the sender can communicate. And I want to restrict the sender to communicate what I'm going to call anecdotes. So this is something immutable, which I can exclude when I talk to you. And so I can't change the facts, but I can decide which facts to tell you. And that's the key part of the communication scheme here. Like, that's the key strategic choice of the sender. So the sender is going to have access to the signal. I've been abstract about what information the sender has thus far, other than telling you it's correlated with the state of the world. Now I want to assume that what the sender has is a set of samples that are drawn from a distribution that's conditional on the state of the world. And for simplicity and mathematical tractability, I'm going to assume the sender also has knowledge of the state of the world exactly, but she can't communicate that. She's restricted to communicating anecdotes or facts. And why am I interested in this? And so those two examples that I had at the beginning of the talk, as you'll recall, one of them was Clinton talking about, or, you know, in the example, it was a president trying to convince constituents to have equality of pay between men and women. And here is a quote from a speech by Clinton. This is an anecdote about two people, a man and a woman, who made different amounts of money at the job that they were, that they both had, this exact same job. And what I love about this example is that this highlighting is not actually mine. This came from an NPR story where they were analyzing Clinton's stump speeches, and they pointed out that she relied very heavily on using anecdotes and stump speeches as a communication device. The other example from the beginning of the talk was newspapers, and this was the front page of the New York Times in May 2020. And as you can see, they very clearly state an anecdote, which is that US deaths near 100,000. They then go on to list 1,000 of the 100,000 that have died from COVID at this point. And so I think that this is another good example of how the newspaper selected a fact, that US deaths near 100,000, and communicated that fact. And there were other facts that that the Times might have selected, but instead they selected this fact. And why did they select this fact, and what impact did it have on their readers? So that's what I'm going to talk about, is the Let's suppose that the communication scheme can only communicate a single anecdote. What I want to think about is what anecdote is communicated? What can I say about the anecdote that gets sent? There's some temptation for bias because, as we've discussed, the sender is going to want to convince the receiver that the state is closer to her ideal point than it really is, to like influence the receiver to take an action closer to her ideal point. But there's also this tendency for accuracy, because for any given bias, the sender's utility function, as you'll see, depends in my model on the variance of the action. And so the sender is going to want to minimize this variance, and hence has a temptation to give the receiver an accurate belief about the state of the world, or at least a low variance belief. We're also going to then see some implications that I think are kind of fun, which talks about polarization of society and whether you'd rather listen to someone who's aligned with your belief system, but has less expertise, that is access to less anecdotes about the state of the world, or whether you would rather listen to an expert who has a different belief system than you. I'm going to do this in the context of solution concepts. I'm actually going to skip this slide because I'll define them formally in a minute. But what we're going to see is that in the context of what I'll define as a Nash equilibrium, well, first of all, what we're going to see is that we're going to characterize the best response functions of the sender and receiver. We're going to see that the sender wants to send an anecdote that's close as possible to a predetermined shift of the state. And I think this is kind of a nice result because it suggests that what the sender does in their mind, like it's a little surprising, but what all the sender really needs to do is to think, how far to the left am I of the receiver? And then I'm going to look for facts that are that far to the left of the state of the world and tell the receiver about those facts. And so the New York Times is just looking for, if you believe the New York Times is to the left of its readers, the New York Times is just looking for facts that are, you know, a bit to the left of the state of the world. And then the receiver's best response, well, sort of naturally, this receiver is going to want to debias, given that the sender is doing this, the receiver wants to debias these anecdotes. And I think that's also kind of cute because that's what I feel like we do in the world, right? We read the New York Times, we think to ourselves, okay, but it is a little leftist. So let me think about like the fact that maybe they pre-selected facts that were left of center. And then we kind of debias it in our heads, and then we interpret what to do. Or we read, Breitbart, and we think that's a far right newspaper. And so we try to debias what Breitbart says. Then we'll see that in this world without commitment, which I'll define as a Nash equilibrium formally, the equilibrium scheme has some bias. So like this predetermined shift is non-zero. And furthermore, this shift grows as the difference in ideal points grows, which you can think about is similar to the Crawford-Sobel result I cited, that like as the difference in the preference misalignment grows, the pooling got coarser, right? So here we're seeing as the preference misalignment grows, the bias gets larger. And it similarly has a welfare impact because the anecdotes that are more in the tail are going to have more variance. And so we'll see that result. And then I'll briefly mention what I think of this as a sort of auxiliary result in the paper, that when you have commitment, this can help overcome the information loss due to the variance of the anecdotes in the no commitment world. Because with commitment, you can commit to, or the sender will commit to unbiased anecdotes, at least asymptotically. And then we can even start to try and think about like, in which settings in the world do we think that the sender maybe has more commitment power, that is like has some reputation that persists over time. Okay, so I'll just wanted to briefly mention that there are other works that are taking data somewhat literally in communication schemes. This is often in a world with a seller and a buyer, and the seller has some facts that the seller can reveal about the quality of the product that they're selling. And what you often get in these models is full unraveling, where if you don't say something, then it's bad news. So you'd better say everything you know about your product. And then there's some more like modern work that looks at partial conditions under which you get partial unraveling and so on and so forth. So this is if you're interested in this topic, this is definitely related to our paper, but the models, the fundamental underlying models are different, so I'm not going to get into it. Is there a question in the chat? Oh, okay. So let me go into the model. As I've mentioned, we have a sender and a receiver and a state of the world. I'm going to assume that the state of the world is drawn from a diffuse prior, that is, it's equally likely to be anywhere. This can be made mathematically precise, but I'm not going to do that here. Alternatively, and this is trying to model the idea that the receiver has no concept coming in, is completely uninformed. There are some alternative ways I could do this without a diffuse prior, but I'm not going to get into that. There's these ideal shifts that I've mentioned before. So the sender wants the action to be a bit to the left of the state of the world. The receiver wants it to be a bit to the right. And the shifts are common knowledge. So the sender knows how rightist the receiver knows how leftist the sender is. And then there's these anecdotes that I've been talking about. And so these anecdotes are going to be drawn IID from some common prior. So there's some prior that's parameterized by the state of the world, some distribution, F theta. And the sender and receiver both know what F theta is. And these anecdotes are drawn from this prior. And I'm going to assume that this prior is well-behaved. I need different degrees of well-behavedness for different parts of my talk, but basically it'll be single peaked and symmetric and continuous and, say Gaussian, for example, Laplace, nice distributions. So what are the strategies? The sender is selecting a communication scheme, which maps this set of received anecdotes to a chosen one. So the sender selects, I'll call this pi. So maybe the pi is, say, the second anecdote in this picture. And the receiver then takes in the anecdote that was sent and has an action rule, which maps whatever anecdote that was received by the receiver to an action, A, which is another, real number somewhere on this real number line. And so given the pi and the A, we can define the utility of the sender and receiver, and I'm going to use squared loss here. So the utility of the sender is the distance between her ideal point and the action that the receiver took. And the utility of the receiver is the distance between her ideal point and the action that she took. And notice that fundamentally, both the state of the world and the action are influencing the utility of the sender and the receiver.
So can you, I've got a quick question. So do both parties know the set of total anecdotes that have been drawn?
No, but that's very important. The sender knows the anecdotes. The receiver only knows the distribution over the anecdotes.
Thanks.
And so that's why the communication is useful at all. Otherwise, we wouldn't have any information asymmetry. So the receiver will learn one of these anecdotes. And the receiver also knows how many anecdotes are being drawn. I didn't mention that, but so we know that there's n anecdotes that are going to be drawn, and the receiver knows the distribution from which they're drawn, but that distribution is parameterized by this theta, which the receiver does not know. Then the receiver sees one of these n anecdotes, which is chosen by the sender. Okay, and so the equilibrium concepts I'm gonna use our Nash equilibrium, which is like having no commitment power. Here we say an equilibrium profile is a Nash equilibrium if the receiver is best responding to the sender and the sender is best responding to the receiver, given the knowledge they have. So as you saw in the last slide, the utility here is to find an expectation for the receiver over theta, which she doesn't know, and the anecdotes X that are drawn from theta, and then using this pi s function. And then we also can do the Stackelberg setting, or the setting with commitment power, where the pi, the communication scheme, and the action, the response of the receiver are a Stackelberg equilibrium if the sender knows that whatever scheme she chooses, the receiver is going to best respond to it. And so the sender selects a scheme such that the receiver's best response is the best for her. Okay. So now, in order to understand properties of the Nash and Stackelberg equilibrium, it'll be useful to characterize the best response functions of the agents. And what we're going to see, as I mentioned before, is that the sender is going to be sending, conditioned on the receiver selecting an action that's just a shift of the anecdote. It'll be a best response for the sender to send an anecdote that's closest to some predetermined shift of the state, and vice versa, knowing that the sender is doing something in that class of communication schemes, there is a best response of the receiver that's a shift of the anecdote. So to make that more precise, it'll be useful to define what I call a translation. So this is what I mean by the receiver is just shifting the anecdote. An action rule is a translation if for any X anecdote I receive X and any potential shift of it, delta, the action I take is simply the shifted action of X. So, if an action rule satisfies this, then there's going to be some constant sigma such that the action is just X plus sigma for all X. In other words, the receiver is debiasing the anecdote by shifting it by this sigma amount. And similarly, we can think about the translation of a communication scheme. And we say that a communication scheme is translation invariant if I take all the anecdotes and I shift, when I take all the anecdotes and shift them by delta, the one that the receiver chooses to send is equal to the shift of the original environment, the anecdote that would have been sent in the original environment plus a shift delta. So this translation invariance is supposed to capture intuition that, the receivers are contemplating the bias of the information. And I also think it's very natural given this diffuse prior over the state, because, what's a scheme that's not translation invariant? It would be like send the first anecdote if it's a real number and the second anecdote if the first anecdote is an irrational number, right? That's not translation invariant. And that seems kind of silly in a world with a diffuse prior because no particular number has any particular meaning. And so I particularly like these translation invariant schemes. And I'm kind of emphasizing to you that fact because there will be other equilibria in my model, but I'm going to use translation invariance as an equilibrium selection technique. So let's make sure we're on the same page about what a translation invariant scheme allows us to do. The minimum anecdote is a translation invariant scheme, right? If I send the minimum anecdote, I shift everything by delta, I'm going to end up sending that same minimum anecdote shifted by delta. The anecdote closest to the state of the world is a translation invariant scheme. If I shift everything, all the X's and the theta by delta, then the thing I'm sending is also just shifted by delta. And similarly, and this is going to be the schemes that the class of schemes that we're going to put a lot of attention on, the anecdote closest to a shift of the state of the world is itself a translation invariant scheme. So we can take any for any target tau, we can shift the state of the world by this target tau. We call this a targeting scheme, and then we send the anecdote closest to that shift. So these are all translation invariant schemes, and each of them has what I'm going to call a bias, which is the expected anecdote given theta is 0. Since this is a translation invariant scheme, so because of translation invariance, I'm subtracting out this theta. And so let's think about what that looks like. So I have some targeting scheme let's try to think about what the bias looks like for a targeting scheme. I have some targeting scheme, which is the anecdote closest to theta plus tau, right? And now what's going to be the bias of this targeting scheme? Well, notice that the distribution I assumed was single peaked, and therefore it's denser to the right of this target than to the left. And so the bias is going to be something a bit smaller than the target. So in particular, and this is going to be important, there's a gap between the position of the target and the position of the bias. And if I want that gap to get larger, I'm going to have to pick a target that's farther out in the tail. So this gap grows as the target goes more into the tail. Cool. So now I'm ready to prove to you the receiver best response function. So I'm going to say that the receiver, if the receiver is best responding to a translation invariant communication scheme that has some particular bias beta, then what she wants to do is simply shift, debias the scheme by shifting it back by beta, and then additionally shift it by her ideal point MR in order to get the action that she wants. And this is quite easy to see, I think, because, by the definition of bias, the anecdote that the receiver receives minus beta is an unbiased estimator of the state of the world theta. And therefore, if you remember her utility function, which is this quadratic loss function, only the posterior mean matters to this quadratic loss. And so this is maximized by selecting an action which is shifted by this amount. And the MR comes in because, she wants to move to the right of the state of the world. Cool. And this is graphically what's going on. Now let's think about the sender's best response. So let's suppose that the receiver is doing this thing where there's shifting by some sigma. In particular, in the last slide, we saw that they would want to do that if the sender was using a translation invariant scheme. But let's suppose that the receiver is taking an action of that nature, just taking what I hear and shifting it by sigma. Then what's the best response of the translation of the sender? And I want to convince you that the best response of the sender is to pick a communication scheme that is translation invariant. So the receiver is just shifting the anecdote that she receives by sigma. Then what should the sender do? We can look again at the sender's utility function. The sender, in fact, can maximize this utility function pointwise because the sender knows the anecdote's X. And this utility function is maximized pointwise by selecting the target, which is basically pulling backwards the shift of the receiver, right? And then additionally pulling by the MS, the target point of the sender. So what the sender wants to do is communicate this vertical arrow on the left that I just drew on the slide. But recall that I'm restricting the sender to send anecdotes. So the sender can't send that precisely, right? Because there might not be an anecdote there. But what we can do is instead use this MS minus sigma as a target. And so what the sender wants to do is to send the anecdote closest to the target ms minus sigma, where sigma is the shift of the receiver. Great. So this defines the best response of the sender and the receiver, and will, in the next section, you'll see that this implies the equilibrium that I described. But before getting there, let me just kind of do something a little bit higher level to reason through the best response of the sender. In particular, I want to think about what's driving the sender's choice of bias. So you can think about the sender as picking a target, which is what we thought about in the last slide. You could also think about the sender instead picking the bias of the communication scheme. The sender is deciding how biased do I want to be. And what's driving this choice of bias? Well, there's several things going on here, right? The sender wants to send arbitrary, is unable to send arbitrary signals. And so but that kind of forces her to communicate something, right? Because any anecdote carries information. There's also a fundamental gap between the preferences of the sender and receiver, which is kind of influencing which anecdote she wants to send. And there's also a potential mismatch. An equilibrium there won't be, but there's a potential mismatch between the bias of the sender's scheme and what the receiver thinks is the bias of the sender's scheme. So let me decompose this utility function to illuminate those pieces. This is the utility function of the sender, as you'll recall. Using the fact that the action is a translation, I can rewrite it explicitly, naming the translation of the sender, of the receiver. We also know what the translation of the receiver is. The receiver is going to debias the scheme with whatever she perceives the bias of the scheme to be, and then add MR. So I can sub that in to this equation. And then I can do some algebraic manipulation and conclude that I can write the sender's utility here, where beta of pi s is the actual bias of the scheme, and beta of pi r is what the receiver perceives as the bias of the scheme. And so now you can see the issues that the sender is facing illuminated here. The first component of the sender's cost, or minus the sender's utility, is the signaling cost. So notice that this fact that the sender is unable to send arbitrary signals, that she's restricted to anecdotes, forces her to have some cost, because this first thing here is just the just the variance of what is sent, right? And so if she has access to n anecdotes, there's always going to be some variance to what she sends, because she doesn't have an infinite number of anecdotes. We also have this component that's the loss due to the gap in ideal shifts, which has to be balanced off against this persuasion temptation. So here you can really see why without the signaling cost component, you would get complete unraveling, right? Because the sender, if she just is focusing on the second part, wants to pick a bias that's equal to like the gap in the preference misalignment minus the perceived bias of the receiver. But if the sender does that, then the receiver is going to best respond by believing a different bias about the scheme, which additionally shifts by this difference. And so it unravels to minus infinity. But the reason it doesn't unravel, and I think this is really neat, is because of this signaling cost, right? The fact that she's restricted to sending data, and therefore she always gives some information, and she wants this information to be unbiased. Cool. So I've running out of time, but we've already basically defined the Nash equilibrium, because the best responses give you the Nash equilibrium. And so with this, we've also already discussed that as the target grows, the gap between the target and the bias of the scheme grows. And when you write down the algebra, what you'll see is that the Nash equilibrium can be characterized by this fixed point equation, that a scheme that has a strategy profile, which consists of a targeting scheme for the sender and a a translation, an action that's a translation for the receiver, is a Nash equilibrium if and only if this gap that we've been studying between the target and the bias of the targeting scheme is equal to the preference misalignment. And so now this is like really neat because now we get a lot of stuff falls out of this. So the proof, it's pretty immediate from the best response functions that we proved in the last section. I'm not going to write it on the slides. Existence, you have to use the niceness of the distribution of the anecdotes to prove existence. Basically, you're going to show that this gap grows smoothly and without bounds, and it's 0 at 0. So hence you're always going to be able to hit the preference misalignment. So recall MS minus MR is a primitive of the model, it's fixed, right? But you'll always be able to hit any MS minus MR by picking an appropriate delta. One implication of this is that if we fix the number of anecdotes, then the required offset tau is going to grow with the preference misalignment. So we're going to fix, let's say, 3 anecdotes, then the tau that I need might be something to hit a particular misalignment, might be something not so biased, right? So the scheme isn't going to be too biased if the preferences are somewhat closely aligned. But now as the preferences become less aligned, that is MS minus MR becomes greater, I might need to go farther out in the tail to get that same gap. Okay, so fixing the number of anecdotes, the bias of the scheme is going to grow, or the offset, if you prefer to think of it in that language, is going to grow as the preference misalignment grows. Which means that basically, if you're talking to, there's 2 equally informed senders. If one is more biased or more different from you than the other, has a more different belief system, then they're going to send you more biased information. But the other thing that I find super interesting is this comparative static about having differently informed senders. So let's fix this preference misalignment and think about what happens as I look at 2 different worlds in which the sender has different number of anecdotes available to her to send. Okay, so if the sender has very few anecdotes to send, then she might need to go a different amount out in the tail to hit that fixed preference misalignment gap. And as she has more anecdotes to send, she'll need to go way farther out in the tail to hit that same preference misalignment gap because the density of the anecdotes has grown. And so the bias of a fixed target scheme isn't as far out as it was before, right?
So that sounds kind of counterintuitive to me, but so when n goes to infinity, like basically the more information is available, the more bias goes. Is it like some kind of, I can cherry pick more, or is it like?
Yeah, so the more that's kind of very relevant to this slide. As the number of anecdotes grows, if there's many, many anecdotes, then I'm going to want to go way out in the tail in order to get that gap. That doesn't mean that the sender is necessarily sending less information than one with few anecdotes, because sometimes for some distributions like Gaussian, the variance of something way out in the tail goes to 0. So as n goes to infinity, the variance goes to 0 for Gaussian. But for distributions like Laplace, as n goes to infinity, yeah, your expert who has tons of anecdotes available, but is very different from you, has a very different belief system from you, is going to send something way out in the tail, and it's going to have high variance or constant variance because the variance of the min of n draws approaches a constant in the Laplace as n grows. And so what I think is neat about this is like, it means that if we don't model, of course, there's no action in which the receiver gets to choose which sender to listen to in our model. But if you ask the receiver, you say there's 2 worlds, one in which there's a sender with many anecdotes, but they're super misaligned with your preference, with your belief system. And there's another where there's a sender that doesn't have very much information, but they are pretty close to your belief system. Which world would you rather live in? There are some distributions of anecdotes. So there's some data distributions for which I'd rather live in the world with the misaligned expert. And there's other distributions of anecdotes where I'd rather just talk to the novice that has my belief system. So I think with that observation, I will skip, this commitment world and conclude. I'll flash these slides through. So if you want to go back and watch the recording, you can slow it down and read them yourself. But basically, the conclusion of the Stackelberg case is that the sender would want to commit to translation invariant scheme whose target is 0. In other words, the sender would want to send the anecdote closest to the state of the world. Now, I also in this section of the paper, we describe what the difficulty is. I remember throughout all of this, I've assumed that the sender knows theta, but simply can't communicate it because she's only allowed to communicate facts. If the sender doesn't know theta, we could go through this same exercise, but now the difficulty, and I show it in this part of the slide, is that the sender can then just use her posterior over theta and implement all the stuff we've talked about before, but things get a little messy because the anecdotes correlate with the posterior. And so that makes it confusing as to what the sender wants to send. Like in this example where the anecdote distribution is uniform centered at theta, the closest scheme to the posterior is not the most informative of theta because you'd rather have the receiver learn kind of where this cliff point is in the uniform distribution. So you can go through that in the video if you're interested. We show how to get around that is we grow the number of anecdotes, and that allows us to say something even when the sender doesn't know the state of the world asymptotically as the number of anecdotes grows. So let me conclude. I talked about communication with anecdotes, which results in information loss, but fundamentally also means that information does get communicated because any anecdote contains some information. We saw that this information loss is less, so like there's less information loss if the sender can commit. Well, I guess I skipped that part of the talk, but that was the last section that I skipped, right? If the sender can commit, she wants to send the most representative anecdote. And without commitment, the sender is going to try to pick biased anecdotes, and how biased that is going to depend on the fundamental primitives of the model. If we fix the number of anecdotes, then the bias of what is communicated grows as the preference misalignment grows. And if we fix the preference misalignment, then the bias grows as the number of anecdotes grows. And those two facts together mean that for some priors, the receivers prefer to communicate with less informed senders. And that kind of leads me to a direction that I think is pretty interesting, which is to think about how, now let's try to grow our game and grow the action space of the receiver, where the receiver gets to decide who to listen to. And so we have maybe a social network where people can collect up anecdotes, right? The receiver gets to decide who to listen to, and her choice of who to listen to will be based on both the number of anecdotes that person has, as well as the preference misalignment of that person. And then she'll listen to that person, she'll collect an anecdote. And then in the next round of the game, she'll happen to be a sender, and somebody will decide to listen to her. And so, you can get this kind of look at a game over time in a social network and try to think about how this kind of tendency towards polarization might impact what's communicated and how beliefs and actions evolve in these societies. So thank you for coming to my talk, and I guess I can take questions if you guys have time, or
Thanks a lot. Yeah, that was a really great talk. I don't know if there's any question from the audience. I have one in the meantime. So what happens to the techniques you have and the result of the generalize if there are many receivers? So I'm going back to the New York Times example, for example. If my goal is to convince as many people as possible on aggregate, to take back the example, to go back to the example, to wear a mask, and they don't all have the same MR, what does the proof that this is the right equilibrium, this is the right thing to do for the sender, does that generalize to that setting, or is there like a big conceptual jump from one to many receivers?
I think there'll be a difficulty. So what I would love to say is that the receivers, I guess, if the sender is doing a translation invariant scheme, the receivers will still be just taking the anecdote and shifting, but they're all going to be shifting by different amounts because they have different MRs, which means that the sender who has this, I would love to replace the MR in the sender's utility with the expected MR, but the sender has this quadratic loss, and so I can't interchange the expectation and the quadratic function. So that means I should go back and do a little more work to see what the implication is there. But that's also, I think, draws me to another kind of point that I didn't emphasize here, which is that newspapers, and the one reason I called Clinton president rather than candidate, besides the point that I want to make another point, is that if you have competing senders, then I think this is going to have a lot of sort of implications in that the New York Times, maybe the receivers are more aligned with the New York Times preferences because they're not reading the right people go read the Wall Street Journal, right? And so there's also this with many receivers that and many senders that they can sort of self-sort, and that'll minimize the bias of what gets sent because then the preferences get more aligned.
Thanks. If there's no question from the audience, I can also just stop the recording, and you can feel free to ask questions afterwards if you're not comfortable asking right now. But yeah, thanks again for the talk. And yeah. So I'm gonna post that later online. Please stop the recording.